Dispelling dangerous myths in health and wellness each and every Monday with Dr. Anthony G. Beck. Brought to you by Biohacker Labs. Warning, side effects may include more energy, deeper sleep, better memory, resistance to bullshit, and more cash in your wallet. Consult Dr. Beck with any questions.
Hey, Dr. Beck, you ready to kick off our inaugural Mythbusting Mondays?
Let's do it, man. Let's hang out. Let's blow it up. Truth bomb time.
Yes, sir.
All right.
Let's kick it on gluten and get deep onto the topic. So we have a bunch of slides that I'm going to pull up here. And all right.
Rock and roll.
Yeah.
Well, you know, I saw on I forgot what channel it was. It might have been on Fox or some other thing, but they were doing this little impromptu street interview on asking people what do they eat gluten-free and things like that. And so many people were going, yeah, they're out in California, and they're like, well, what is gluten? You should have heard the range of answers. They're like, well, I don't know. We're just supposed not to eat it.
Yeah, that's all I know. Everyone should stay all the time. Do not even come close to it, because if you're sitting in the same room with gluten, chances are
you'll mess up your digestion.
Yeah, your digestion will be screwy, and you'll have to go to the hospital real soon.
Yeah. Well, listen, it's what I call my Clint Eastwood, balanced understanding. You got the good, the bad, and the ugly. And so what we can do is just lend some understanding into this, and I'm really excited about these editions of Mythbusting Monday, because they're going to be hopefully clear and concise. I'll try not to ramble on too much, but that's going to be a challenge in itself. But I promise I'll try to be brief and not too doctory. So here's the thing. So let's get right to it. The truth about gluten starts with understanding what it is, where it comes from, and then we can go on to possible effects in the body and things like that. Well, gluten is a particular protein that is found, if you remember back to sailor biology back in high school and stuff, the endosperm of grain. So basically the seed of all grass will contain gluten, okay? But we're going to clarify this understanding of what gluten is, here just a little bit. But it's the part that science, has been trying to manipulate to get more of, because that's the part that we extract out and we grind into flour, and we like to make all kinds of baked goods and things like that that make our thighs get big. So the fun thing is it is found in all grains, but I want people to understand of gluten is a generalized term. It's kind of like saying automobile. Okay, well, they're all automobiles, but who's the maker and what's the model of the maker, right? So you just like if you talk about, okay, you have luxury cars, then you have American made and so forth and so on. So there's a breakdown. So what we did was I created this next slide to kind of give us that breakdown a little bit, to look a little bit more deeper into this understanding. So like I said at the beginning, all the grasses actually have a common thing. If you remember going all the way back to family and subfamily and phylum and kingdom and genus species, all the way back in science again, they're all grasses. If you think about it, most people don't think, well, corn's not a grass, but then if you look at it, you go, well, I guess it is. Same thing with rice, same thing with wheat and barley and rye and all these kind of guys. So at the end of the day, basically what we do is we kind of have these subfamilies, and then we will call these tribes. And some of these, I guess, in the slide are kind of missing, but follow the arrows and you can kind of see what's going on here. When it comes down to grains, again, understand this to be the seed or reproductive organ of grasses. Really simply put, is that. The interesting thing is that there are different grains that have different prolamines, okay, that are the actual type of gluten, if you will. So every grain has its own gluten. So by the definition of gluten, wheat will have gluten, barley will have gluten, rye, oats, even some of these other ones, rice, corn, sorghum, millet, teff, and stuff like that. Now, the interesting thing is to understand that each one of them has its own gluten. So oftentimes you'll see products and it will say gluten-free. Well, and because it might be made with corn or rice. Well, by that statement, it's really not true. So this is where some of the confusion can come from. Indeed, it does have a gluten, but not one of the glutens that are in the toxic gluten families. Does that make sense?
Yeah, that does. So a prolamine is a gluten? Is
Correct.
that
Yes. Yes.
Okay. So what you're saying, that any kind of grass actually contains a form of gluten.
They
That's
just
correct.
purported to know what kind is good or what kind is bad. Right?
That's it. Yeah. So an automobile can be a truck that has a diesel exhaust that can be more toxic, put out all that sulfur and nastiness, or an automobile could be a hybrid and it runs on electricity. It's not going to put out the exhaust. Does that make sense?
Yeah.
Auto. So we do have gluten is a confusing term. So I want people to realize when it really comes down to it, you just have to educate yourself on terms and make sure we're dialoguing about the same thing. So where the family of glutens or glutenins and things like that are coming from is the toxic group that's to the far left diagram over here. When we're really specifically talking about the problems associated with gluten, we're talking about wheat, barley, and rye, to be quite frank. Okay. Now, but some people, and we found clinically, and there's a lot of scientific literature on studies on this, that they can also have gut and disease, if you will, conditions associated with rice and corn and sorghum and some of these other supposedly non-toxic or gluten-free grains. Well, I want to expand your mind and make sure you understand a little bit more about why that is. So in this next slide, we're going to show what actual gluten is. One of my colleagues in functional medicine, Alessio Fasano, he's done a tremendous amount of work in the field of gluten. And so this is a diagram, courtesy of him. And what I like to kind of bring your attention to, okay, is the fact that basically gluten is a protein. Okay, let's keep this real simple. And a protein is a sequence of amino acids, kind of like beads on a string. Okay. Now, of course, there's a lot of, if you get to advanced biochemistry and the structure of proteins is basically how they're classified. Different parts in this sequence will determine, these colors represent different portions of it that actually enact certain reactions in the body, okay? So basically, if you take a look at that red little sequence there, all the way from 30 to 43, those different amino acids, though this particular alpha-gliadin motive, if you will, is the one that actually exerts the cytotoxic activity on the body. Then there's another part that you'll see there in green that is the immunomodulatory activity, right? Then there's another part that makes it what we call it zonulin release. So the body will actually produce a chemical that we now know that we can are beginning to realize that we can quantify the amount of leaky gut status based upon that zonulin there, creating that permeability, and so forth and so on. So when it comes down to it, you also see that dark green portion down towards the end. This is a particular a portion of this string of pearls protein that will lend to a release of interleukins and inflammatory compounds in celiac disease. So the take home here, to make this simplified, is that when the body eats a protein from a specific source, whether it be animal or plant, it now has the objective to go into the stomach, get denatured to a certain degree by the acid, then go into the small intestine. Then we have different secretions and things that are involved in its actual digestion, which is by definition breaking up of this chain. Some of the parts cannot be recycled or used, so they do enact a particular potential problem for certain people, and it's based upon the structure of this protein. I'm going to talk a little bit here in a little bit of why I feel that this has become an issue. Okay.
So I have a quick question for you, because this could be a little bit confusing, as it is a little bit for me, but I just want to make sure that I'm getting it clear. So what you're saying is when someone eats a rice or whatever it is that could potentially have gluten, it's broken down into this chain, a protein chain, and there's parts of that chain when they're metabolized that could break off, that could be problematic. And what we're looking at here are those areas of proteins that may or may not cause issues.
You got it.
Okay.
That's it in less terms, and so that's really what it is. Proteins are strands of organized amino acids in sequence that the body has to break down in order to use. In certain species of grain, some of these proteins are not able to be broken down in the body by our current enzymatic capacity, based sometimes on chemistry, sometimes on genetics. If the ones that do end up coming through that the body will want to absorb and bring in can also set off an immunological reaction.
Mm-hmm.
So this is what we're talking about. Proteins have to be unfolded and and broken up into sequence and for the body to use it to get certain cellular responses. So yep, that's it.
Got it. So the breakdown and determination of how your body breaks down will dictate whether you're allergic and have a reaction to
That's right.
whatever it is that you're
Certain type
eating.
of-
Okay.
That's where the rubber hits the road, and then your body's response to that segment. Some people, it's more upregulated than others. Okay,
Right. And
so
yeah, and the only way to really know is to find out what your biology looks like and how it reacts to these little chains.
got it. Everybody is different, and how we'll do that is look at the next slide where we're actually seeing some of the structures of the intestines and that are involved with it. And some people, again, will remind of these things, but I like to let people know that the small intestine is what I call your inner tube, or down south we say the hooter tooter tooter. Okay, so the upper part there has all these villi, these branches. Okay, and in them, this is where the vascularity is. You can kind of see the artery and the and the vein, or the exchange there. There's always the the electrical, like a circuit. So when it comes to vascularity in each one of those, and then on the surface of each one of those is a single cell layer, complete with microvilli. And what the body does is it responds to foodstuffs that come into the intestines, apply certain enzymes and things to digest these proteins, because remember, we need to break them down into smaller strands and then cut those little lengths of ribbon down into little snippets of ribbon, and then they have to come through these gates or channels or these tight junctures. Well, the interesting thing is when the body has a fortunate set of events for different people, it's all a little bit different, and you're putting through these particular gluten-derived proteins, the body will actually sense the harm in their structure down to the cellular level, and the body will actually assign it an immunological response. But I like to cause your eyes to look over here to the upper right-hand corner of this particular slide and see that those little gaps is where foodstuff actually has to come through there in response to those particular epithelial cells. And then down to the bottom right, you actually see an image of exactly what they look like. It's very similar to the actual diagram. So in the next slide, we're actually going to see a representation of the immune response to it. So here we see the gluten come in, the microvilli respond to this particular structure based upon receptors. And then if the body feels it's foreign or it creates a cellular response that's not desired for it, our macrophages or our immune cells are going to take it in, and they're going to send the message to T cells, which are going to release cytokines, these inflammatory chemicals, okay, and in response to it, but then also send a message for future reference for the B cells to produce antibodies to it. So the trouble here is when people are gluten sensitive or these proteins are not able to be digested, the body knows that it's harmful, and so it wants to send out a forever signal to when they come into play to where you better bind these antibodies to them, and we need to label them for destruction. And also create a symptom, so that way hopefully we'll tune into it and go, well, you know what, we need to not be consuming these. So the problem is these inflammatory responses of our immune system will erode and flatten out this microvilli. And when that microvilli has that, what ends up happening is now the other foods that we need to take in that rely upon that structure, that's impaired too. So we get all kinds of reactions in the body from this particular response, all from the gut. And then of course the good bacteria that does so many things in there, and that biome that protects us doesn't have any of these little shag carpet microvilli to populate and create that little protective slime, kind of like a largemouth bass or a fish would normally have for protection. Does that make sense?
Yeah, it does.
Yeah, so the thing is, that's the reaction to the protein that the body will respond to immunologically. So again, this tells us that glutens that are of a toxic nature that we had already talked about absolutely can and contribute to a pro-inflammatory response of the human immune system that can create this structural issue, which can lend to a partial causative factor for just a whole myriad of what we call diseases. So anywhere from depression to schizophrenia to allergies to respiratory distress to cardiovascular disease. I mean, we've really linked it to over 200 plus catalog diseases. So it does have some involvement. However, there's a lot of people that consume it that don't have this particular reaction. So let's move to take a look at the next slide and see how this kind of works when it comes to a response. So this is kind of a zoomed in version of what I was just talking about. So this particular gliadin, which is the prolamine peptide associated with wheat, for example, it basically creates this reaction and the release of trans-glutaminase, and then this is presented to what's called an HLA, right, or this human lymphocyte antigen. In the DQ2, there's a sequence based upon your genes that makes these particular cells. And if you have a certain genetic predisposition to these DQ2 and DQ8, so to speak, your body will have a greater receptibility to these peptides to cause you to have these immunological reactions that thereby go and destroy those cells that we were talking about, the epithelial. So there is a genetic component or a predisposition to this, and we've identified those for people who tend to be more prone to actually having celiac disease, which is not to be confused with a gluten sensitivity. Virtually everyone has a gluten sensitivity, but whether it creates a disease or erodes it, that is to be established on an individual basis. Now, some of my colleagues absolutely proclaim and position it that nobody can digest gluten, but I'm going, well, what gluten are they talking about? But let's say gliadin is the most biggest common culprit, which might be the case. However, if your body has a greater resistance in here, if you have an enzymatic sufficiency, if your gut biome is in place, and we don't have large doses over huge frequency over the day, over weeks and months, the body can actually handle that particular thing, and that's been my experience clinically. But here's one of the interesting things, and we'll see this next. When we're talking about cells, in this particular next slide, is we're seeing what's called cross-reactivity or molecular mimicry. Now, remember I was showing you that there's different proteins for different, or in different glutens for different grains. Mm-hmm. Well, the thing is a lot of times they are very similar in their shape and structure. So what ends up happening is let's say the body creates an immunological reaction to that gliadin from, say, wheat, and so you have a complete binding to this antibody. This key goes in the lock, okay? But then there are certain ones that are similar, and there's some that are different. So like you'll see, like sweet potato there, it might have a particular protein in it, but it doesn't even fit in the lock. It's kind of like when you go to the hardware store and you get a copy made, they have to know what blank to use. Mm-hmm. Well, you can oftentimes get the same blank and it'll stick into that classification of lock, but it won't tumble your tumblers. Mm-hmm. But here's the interesting thing about the body, is you can take a protein structure like, say, casein, which we actually get from cow dairy, and it has a very similar structure, so it'll go in the lock, won't necessarily tumble the tumblers, but it will bind that receptor and cause the body to have very similar immunological reactions to it. So that's what we call by cross-reactivity. This is actually what happens to a variety of grains that are non-toxic based upon their sequence of those amino acids, but can oftentimes yield very similar results to individuals. Okay? So again, in this next slide, I'll show you, this is the list of very commonly reactive foods. So we see rice, barley, spelt, different milk caseins, and so even whey protein that you think you're supplementing. And let's say we've established that you're reactive to gluten from grains, and then you remove those, and oftentimes people still have the symptoms, and they'll go, well, man, it must not have been the gluten, so they'll start eating that gluten again, and then there's this vicious cycle. Well, the problem is this molecular mimicry. Everything from yeast to sesame to instant coffee, buckwheat, and then looky here. Most people go, well, I'm going to get rid of those, and I'm going to start eating the heck out of some quinoa. Well, the problem is when you do that, you increase the potential of an immunomodulated response to a protein that's similar, right? So it's a case of mistaken identity, and you'll still keep having the symptoms. So there is some, art to the science of medicine on working with these particular things. And it goes right down the line to soy, to egg, to corn, to rice, even potato. Okay?
The molecular, the mimicry, so does your body confuse itself with the actual gluten and attack itself? Is that what's causing the
That's
damage?
correct. So in other words, you had that foreign protein from, say, gliadin, right, from wheat, come in and create damage because the body couldn't break it down. It leaked in there. The body responds immunologically with those macrophages. Remember, it tells your cells to respond, and then from now on create antibodies to it. Very similar to what we try to do vaccination-wise, right? So we give you some of the virus, and then the body remembers it. It gets encoded, then we're able to create antibodies to wherever it shows up again, we can respond correctly. So that's the same kind of thing that actually happens to with certain foods. So what ends up happening is people create a sensitivity to a toxic form of a protein from a grain, and then what ends up happening is then the body will create antibodies that are very similar to some of the other proteins that come from these other foods that aren't, say, toxic to you, but when they go in and they fit into those antibodies, the body will think that it's the same thing actually doing it.
Yeah, it's interesting because even when we have friends that have a gluten sensitivity or allergic to gluten, most of the cases, they are also allergic to dairy, or so they think, right? Because
correct. Generally, it's that molecular mimicry. Now, however, we're trying to simplify this. There are some other things that contribute to that dairy reaction too as well, because dairy does have some other similar responses too, depending upon what other maybe hormones were present that they consumed it. When you start thinking about these chemicals like antibiotics and growth hormone analogs and stuff that they shoot into cows, it's different. And again, when we say dairy, that's going back to that same analogy of automobile. Well, what dairy? We're talking sheep dairy, goat dairy, buffalo dairy, cow dairy. It's these generalized terms. So when everybody goes, well, gluten is bad, I'm going, well, which gluten are you talking about? Well, avoid dairy. Well, what dairy are you talking about? See, we have to have this balanced understanding in this little talk about it.
And I assume there's degrees of sensitivity, right? So
there sure are. This is why we actually take a look at these IgG and IgA combined ways of looking at it, because each immunoglobulin, which is the Ig stands for, has its response, its shelf life, how long it's active, right? And what tissues does it respond? So it's actually what I call the immunological game, because we have IgG, IgA, IgM, and IgE. So each one of them, manifests in different ways. So without getting into too sciencey for all this, the take home here is that there are foods that are cross-reactive to toxic family groupings of glutens that can cause the same reactions in the body as if you were actually eating the toxic gluten protein itself. So we have to be mindful of that if we're ever trying to get to a resolution of chronic disease with origins down into the GI. Okay.
I have a question on this slide here. So cross-reactive foods? Can you kind of go over that one more time, just so I'm clear on what that means?
Okay, so what happens is you have that protein sequence of a gliadin protein.
Yeah.
The body realizes that it can't break that down, and its presence is causing a reaction in the gut mucosa or the epithelial cells. So the body says, okay, we think we're going to label this person, this entity, as harmful. So we give it to the immune system. The immune system goes, okay, let's take a wanted poster, a picture of this guy, and then start a rap sheet. Take its little snapshot, holding a little code like in jail. Not that I've ever done that. But right, and then the body takes that picture, posts it up in the post office. So anytime that criminal who's wanted comes in, they'll do it. Now, if that criminal had a certain profile, height, and demographic, and all that kind of stuff, but what if it was its twin? What if it's something that looked like it, like its older or younger brother? It might be mistaken for that. So the body's going to go, oh, looks close enough, and it responds immunologically to it. So it's a case of mistaken identity, but yet the body responds the same as if it was there.
Wow.
Other protein molecules, that is a very common thing. So this also explains why a lot of people will say, well, avoid egg or avoid soy or avoid grain. Well, when it really comes down to it, I like to let patients know that it behooves us to really pinpoint and get to the root cause and not wrongly accuse somebody of a crime, right? And that applies in the body too. Now, you can take global precautions and avoid all of them and do an elimination diet and then reintroduce. That is a technique for self-guided. However, we do have some very simple and affordable tests that can save us all that guesswork and allows us to get a baseline of what we're reactive to, avoid it for 3 to 6 months, and then we can retest with a reintegration of that and see if the body still will make that antibody to it. If it is, well, then you've developed basically you can consider a lifelong immunological reaction to those particular proteins.
So is there a way for our cells to be like, hey, you're going after the wrong guy and take that?
It can. Yep. So let's say you had some gliadin go through and you wrote everything, make that response and things of that nature, and then of course we had some dairy react to it, we had some egg react to it, and all that. You know, it was hanging out with the wrong dude. Well, let's say we stop all that for a while, and we have some healing time because the gut heals so fast. It's just a wonderful thing. I'm talking out within a day or 2 to 3 days. I mean, it's just a repair machine. So there's a lot of light at the end of the tunnel. And then, but I like to give it, a longer period of time, generally 3 to 6 weeks minimum, because that's how long those immune cells that were there when the APB was sent out over the radio. Okay, you got to wait for all those guys with that memory to die off. So generally 3 to 6 months is a good time to clear out all that. Then you can reintroduce, and they'll go, oh, I'll take that corn. That's fine. Oh, that rice is fine.
Really?
Oh, that quinoa works.
It won't confuse it again?
No. Because remember, it's based upon not a picture, it's a molecular mimicry. It actually is responding off a membrane signaling structure of the protein itself. It's so the sequence.
Is there an intelligence at play that actually says, oops, we made a mistake?
Well, not oops, we made a mistake before, but it's like now it's not doing that because see,
the picture was deleted, basically.
Yeah, the picture was deleted, and now we're clear.
Yes, that's correct. Yeah, you got it. Best way I can explain it. So most people aren't aware of cross-reactivity or molecular mimicry. We all understand food gets broken down into tiny components, and the body has to digest it, absorb it, reconstruct it, or utilize it. And when toxic ones come through, it becomes an issue. But then the question is, and let's move on to the next slide and kind of get an idea of how we discern the difference in those. So again, we have gluten-related disorders and these different, what we call in medicine, pathogenesis, or the pathos or disease genesis or origins. Okay, so the body can actually have an autoimmune response. It can have an allergic response, but not autoimmune. And then it can actually have a non-autoimmune, non-allergic reaction. Okay, so we go down to that next tier, and we can kind of see that. Remember, you can have an autoimmune reaction to those toxic family of proteins, and for some people, if they have that genetic predisposition of that HLA D category allele in their genes, they will manifest over time a disease. So celiac disease is different than a gluten sensitivity. And then even in celiac disease, sometimes it's symptomatic, sometimes it's silent, but then sometimes it's the potential. It hasn't kicked off yet. And this is why we actually will see people getting this diagnosis of CD or celiac disease. Generally, 20% is actually over the age of 40. Okay, so you can have this particular predisposition and actually be asymptomatic for decades of your life and have no idea. It's not actually pronouncing itself as celiac disease right now, but it could be lending to such symptoms as migraines, menstrual disharmonies, actually having miscarriages, bipolar, all these diseases, these stamps on your forehead, all have been linked unequivocally to a gluten sensitivity in the gut. So we got to be mindful of that, okay? But then you have the classic other autoimmune things like dermatitis herpetiformis or gluten ataxia. Those proteins actually are these actual beads, these little strands that enact a certain signal on the cell membrane of certain cells and tissues that cause it to have dysfunction, right? So it's a very interesting concept to see that autoimmune thing. But then there's those of us where it's not necessarily autoimmune, but their body has developed a reaction or an allergic reaction to it. So then people can actually have an acute reaction to something like that, or exercise-induced anaphylaxis from wheat-dependent exercise-induced, or they can actually just have contact reaction on the skin just by say handling it or actually breathing in flour, right? You can have an allergic reaction to it. So, not to get too crazy in that understanding, the bottom line is gluten does and can potentially create certain reactions in the body. But what I like to do is kind of myth bust to the degree that people talk so much in absolutes, okay? So let's take a look at the next slide and see how this kind of actually works. And I like to just briefly show this, won't too much into it. But if you remember back to advanced biochemistry or things that you do in cellular biology, basically what happens is the gene, whenever you have a protein that's, stored, it's a blueprint stored in the nucleus of a cell. It's emitted in response to cellular stimuli, and the body says, hey, make this. So it basically has this little on-off switch at the beginning, then it runs through the ticker tape thing, and then it says, okay, here's this protein, and stop making this sequence here. Kind of like that, those pearls along the string I was telling you about. So then that messenger RNA actually tells the body to actually go to another organelle in the cell and here's your copy, make this particular protein, okay? So that's actually how that happens. But the question is, why is that pertinent in this particular case? Well, in the next slide, you'll understand why. Because the question is, why are some people reactive to gluten and others are not? Now, I am not a fan of genetically modified things that are protein-based, and I'll tell you why. Because as our bodies developed and adapted over time to our environment and our food stuff, it actually, the body knows how to develop programming in the DNA for future consumption of these other protein sequences. The problem is when science starts manipulating that and jumping us ahead decades, if not centuries ahead of what the body has the capacity to break down. So I'm just using corn for an example. They do this in wheat. They do it in all grains. Because remember, suppliers of these food stuff do it because they get paid on bulk, on volume, and how much more bushels we can produce. So, of course, they want more. So they put fertilizers and chemicals out there. But then we've got the natural environment, bugs that want to eat it too. Well, if they eat, 1,000 bushels over acres and acres and acres, well, you add that up, it really hits into your bottom line. It's just like you see like a box of cereal, and it used to be, okay, 32 ounces. Now it's 31 5/8. Well, because they realize, well, if we shave off just that little bit and keep the price the same, look how much more money we can make. That's what happens when it comes here. So without getting too deep into here and beating up on the evil Monsanto, yep, not a fan at all, they want to ensure their profitability. Okay, so basically what ends up happening is you'll see a situation where they will take this particular, if you call up here, and they will snip out the part that they know that this particular bug won't eat if it comes into contact with it. Okay, so they manipulate the gene, force it into the sequence of the other genes to give it the characteristics to resist Roundup and bugs from eating it. and then now put it back into the plant and say, now here's that blueprint, that start, turn on and off at the beginning and where to stop, and still make this particular plant. Well, the trouble is, yeah, the bugs don't want to eat it because they're like, wow, that's toxic. Our digestive system can't break it down. Well, guess what? The humans can't either. You see? Mm-hmm. So at the end of the day, gluten has become a problem because science, in trying to respond to putting more of that out there into the global commodities market, needs to expand their supply. It's just like fast food trying to, they don't want to use a dairy product when they can just do it cheaper with an oil and make it, like an artificial, cheese. Right? It's a lot less expensive to produce and makes more profit. So what ends up happening is they've manipulated the grains, which has manipulated the proteins, which now come into the human body and are foreign to our enzymes and our cellular responses, which yields the immunological problems. Does that make sense?
Yeah, so how is that related to gluten specifically? Because I understand how, like, for example, corn, if it's modified, genetically modified, then your body won't recognize it and won't know how to break it down. But what's the connection between that and gluten? Will it attack it the same way?
That's correct. So they do the same thing with wheat. Okay, so wheat's sequence is already one that has a potential based upon its adaptive or evolution in the plant kingdom of producing proteins that are difficult for us to digest. And remember, that's why that first slide I was showing you, that endosperm in there is where all this protein is, and that's the stuff that we want more of, greater weight, and not bugs to eat them, and we don't want it to degrade if we spray Roundup on it. Okay, so we want to make proteins that are more resistant to that. Basically, create these superheroes, these Captain America versions of the soldier. You see, and so corn is that way, wheat is that way. Most of these large commodity grains are that way, but specifically wheat, rye, and barley are that way. They genetically modify them to where those proteins in that endosperm, bugs don't want to eat it, bacteria and fungus don't want to eat it, and pesticides don't degrade it, so that way they can grow lots of it, dry it out, ground it up, make flour, and then all the fun ho-hos and ding-dongs that we want to eat, right? And hot dog buns. So how that applies here is that's where that protein is. That's where those sequences of those little amino acids on those strings, if you will, create these sequences that the body doesn't have the ability to break down, just like the other organisms don't have the ability to break down. So we thereby consume those, and the body it responds immunologically in a variety of different symptoms. Different lights go off on the dashboard proverbially and tell us, hey, don't eat those. But we don't contribute it to the glutens. Make sense?
Yep, and it also makes sense why there's a lot more causes of these instances of gluten allergies, because there's so much more GMO out there.
That's correct. If it's not labeled non-GMO, you can be assured that it's GMO. Now, let me give what I call the balanced understanding of gluten. Now, being a good old boy from North Carolina, it's highly improbable that for the rest of my life I'm not going to have a plate of biscuits and gravy. Right? All right, if I'm going to be out in San Diego with you guys, and we're going to go to a ball game, and I might not want to get a stadium frank, okay, and wrap it in that whatever. Life can be okay that way. It really comes down to everyone's own biochemical and genetic uniqueness. So to talk in absolutes that gluten is globally bad and terrible for everyone, I do not find that to be correct, and I don't find that to be correct after a couple of decades of seeing tens of thousands of patients. However, I do make the caveat that if you do have any and all chronic disease, you do want to evaluate for you if gluten is actually a part of the problem. If you're free of that kind of stuff, well then you probably can be fine. But the good news is it's very repairable because of just the virility of strength that the GI has. If you think, what do I need to add? Good bacteria, beneficial fibers and roughage and vegetables and good nutrifying stuff. What do I need to remove? Other things that could be degrading it other than gluten. Alcohol, bad fats, bad microbes. Too much of a good thing, a fermented food, maybe not enough. There's this balance here. So you got to think about, what do I got to add and take away across the board that could be contributing to my body not having the strength to respond to these proteins. Make sense?
Yep.
So I tell people you have to determine that for you. So I'm in the middle. There is some people that I don't see have those particular reactions to it. I have patients internationally, and their sources of grains are not the same ones that we have over here, so that they're not necessarily causing the same reaction. So again, I'm really protective of the universal statements of gluten is bad for everybody and everyone should avoid it like the plague. I don't think that's correct. However, if you do have a disease state or a chronic state of ill health or something, always make your due diligence to evaluate if these glutens of the toxic nature could be causing the problem directly, or some of the other foods that you're eating might be manifesting the same reactions due to being similar to or having been in the history of consumption of those toxic glutens.
Yeah, makes sense.
Yeah, hopefully that kind of brings it around. Real simple. So that's what I feel about the truth about gluten. We can do without it, I mean, quite frankly, but at the end of the day, it really comes down to where do we find ourselves? One of my colleagues, Dr. Tom O'Brien, he's a big, a gluten speaker, and he's just an awesome gentleman and a scholar. I love him to death. It's not a matter of necessarily what you believe. It's actually what's really there and applied to you. The only answer is to really test and determine how it applies to you. Now, that can be a lengthy process and sometimes a monetary investment. But it comes down to understanding that you can have a gluten sensitivity, and virtually everyone has a great potential to be gluten sensitive. But to understand that what it manifests as far as diseases of celiac disease, diabetes, thyroid disruption, lupus, autoimmune stuff, fibromyalgia and chronic fatigue, and psoriasis, skin issues, and then of course bipolar and schizophrenia, these psychological issues, even degrading blood and creating anemic states, is very true. It may and can contribute to these diseases. However, it's not an absolute statement. And so please just distinguish the difference here of the word gluten and the difference between having a sensitivity versus it creating a disease in the human body.
Yeah, well, it's kind of scary too that it could lead to something that's silent like celiac. So it's really important to just find out, do a quick test to find out whether you have gluten sensitivity and if you're allergic to it, and then act accordingly.
And I make these available to patients across the country. It's very simple. It's quite affordable. It's not painful to do, and you can do an assessment, and then you can basically get a snapshot once and for all to know. So that way you have some information to make an educated choice. It's just like other topics like oral contraception. It can do and be beneficial in a lot of things for a lot of stuff. However, it also has a record of being kind of naughty. Okay, so everything has that potential, whether it be gluten, oral contraception, heck, vitamin D is fantastic, but again, too much of it can create a toxicity. So it's all about finding balance based upon your own individual biochemical uniqueness.
So that's all we have for this episode of Mythbusting Mondays, brought to you by Biohacker Labs. We're on a mission to open 1 million people's eyes to the real truth about health and optimal wellness. So please help us by sharing this podcast with family and friends. And together we can break free from all that noise and confusion and make the world a brighter place. Remember, each episode comes with a video and slides, so make sure to head over to www.biohackerlabs.com/podcasts to get them, as well as our show notes and some free gifts.
And subscribe to our YouTube channel and podcast to discover more dangerous health myths. We love hearing from you, so please share your thoughts in the comments below. And if you have a show suggestion or want us to bust a myth, please email it to us at mythbusting@biohackerlabs.com. See you all next week with a fresh myth-busting episode.